All right. So our third lesson on our AWS Certified Cloud Practitioner crash course is going to be talking about billing tools. Um, but it's also going to be covering some of the technologies that we use and talking about them along the way. So the challenge with pay as you go is if all of a sudden I get 10,000 new users, and there's way more traffic, and my auto scaling load balancer creates a whole bunch of new EC2 servers for my API that I built, then guess what? My AWS bill shoots up like a rocket. So cost management is a huge deal, as is optimizing the AWS usage. And this is a non-trivial task. As junior software engineers, you all won't need to do this, but it is good to learn about and have in the back of your mind to start to have an understanding of what like real world costs of computing resources are these days and things to think about. So we'll cover the AWS pricing calculator, cost explorer, budgets, and billing alerts. Um, and Um, I apologize, I lost my train of thought there. So we're going to cover these core tools for AWS billing, and I'll show a bit of them along the way. So there is a tool called the pricing calculator, and its job is to estimate costs before launching. On the exam, your trigger phrase should be forecast cost before deploying. If you hear before deploying forecast, think pricing calculator. Cost Explorer is to look at past and current spending. So analyzing current monthly usage, monthly AWS usage, Cost Explorer. AWS budget, setting spending limits and alerts. So this is for notification. Notify when cost exceeds X dollars. And then related to that, billing alerts for an email alert for changes over a cost threshold. So if you see exceeding a limit, send an email. So these two are a little related. So let's walk them through them in a bit more detail. So the AWS pricing calculator, and let me go ahead, in fact, and pull up my code platoon AWS, and let's see what we can see here. And they may have replaced it with the billing conductor. Um, So I'm not going to worry too much about here's cost and usage report, here's cost explorer. Um, let's do a quick search. There we go. So AWS pricing calculator, estimate the cost of an infrastructure, and you use it on your AWS account. You tell it what AWS services you want to use, some configuration details, and it will give you an estimate of that cost. So if I'm spinning up an infrastructure for a company, I'd use this before launching the resources. It builds an estimate based on my configuration, can export to a PDF you can share with stakeholders, use it for planning architecture costs. Cost Explorer. This is for looking at the money you're currently spending for tracking historical usage and cost trends. And in fact, if we go to Cost Explorer here, we can see it in the console. And in fact, we can see here a real Cost Explorer setup, though we're not spending a lot on this AWS account. But here you can see Cost Explorer lets you see my monthly spend month over month. And I think, no, I don't think we're seeing the AI cloud ops people here because I would expect to see like databases and other things. But you can see that it's not a massive amount of money, but like those EC2s can start to add up, and you get charged for a virtual private cloud. You get charged for a domain name on Route 53. There's some recommended actions and stuff like that here. Um, and you can play around. If we had different regions, we could see cost groups by region and so on. So the Cost Explorer This is just sort of the tip of the iceberg with it. It's actually an extremely powerful and somewhat complicated tool. So you can see these nice graphs to see budget spends and things like that, and view daily, monthly, or forecasted trends. And that's the AWS Cost Explorer. Next, if I want to set a threshold, so I could get an email or text message alert if suddenly traffic spikes because of lots of new users, I would use AWS budgets. Let's see if we can see this one. And we might just search for this one in Google. And again, this is about monitoring and alerting for my cloud costs, right? So it's very useful to get an email if suddenly like my cloud spend like spikes by 200% for like more than a couple hours. It can also forecast costs ahead a little bit. And this is for budget enforcement. And then finally, we have billing alerts, which can set up billing alerts in your cloud preferences that something has gone over a threshold. You can use CloudWatch, which is a notification service, and you can send notifications to an email message. And this is the quickest way to get notified if you have a billing spike, right? So we have these four tools that we're going to use here for our budgeting. And we have an extremely big text. So those are the budgeting tools, and that section's pretty straightforward. Let's just dive in here and just do a little practice questions. I know some of these are a little bit of gimmies. Some of these are a little tricky. I think it's good for us just to talk through and do them. And I'm just gonna call on folks in the randomized order that I pasted here. Um, so, oh, Ryan, you added yourself to the top of the list.
Just just because I wasn't on there.
My apologies.
No, no.
I used the same list from yesterday and I randomized it again. So thank you very much for doing that. Much appreciated. Ryan, so what tool do I want to use for future AWS costs before I launch a new architecture?
See the pricing calculator.
Yes, sir. There we go. Next up, I believe, is Cricket. If you want to visualize how much EC2 cost your team last month, what tool should you use?
Uh, Second one, history, Coast Explorer B.
Yes, sir. Good job, guys, and thank you. Um, Next up is Rick. If we want the user to get an email when the AWS bill goes over 100, which one of these tools should I use?
Um, the billing alerts. That's what B. Yeah.
Yeah, AWS budget or billing alerts. They kind of overlap. And this question I always get a little wrapped up and confused on. So, Chris, what's your best take on what's the key difference between AWS budgets and billing alerts? And let's see.
I'll go D maybe.
Got it. So the answer here is B. And this is a good way to remember it, I think, right? An alert is about alerting you when you hit a threshold. Like it's sort of a ring the alarm bell in terms of cost management. Budgets is more of like reporting and notifications because I can like forecast what my costs will be by the end of the month. But billing alerts is more like, hey, like you have like you're spending way more on EC2s like this hour. Just to kind of walk through these, um, I just kind of want to point out, I would actually say C and D. To me, the fact that they start talking about these more technical things, makes me a little suspicious of these questions. So because on the exam, you're gonna see questions where you're like, ah. I don't know. Trust me, I saw a lot of those. And I think it's useful to kind of build that like test taking mindset. And just from that perspective, C and D feel a little more suspect to me. So if I was to sort of triage, I would put them like low on my list and basically choose between A and B. Chris, thank you, sir. And up next, Tony, what billing tool is best for sharing a cost estimate with a client or a stakeholder?
Uh, B, the pricing calculator.
Yeah, yes, sir. Pricing calculator is very good at doing this. Um, awesome, guys. Thank you. The billing stuff, I think, can be a bit more straightforward, and so you can get some easy answers out of this on the exam. We're not going to walk through the hands-on exercise today in the interest of time. And just 1 minute, Tony. But if you do want to do this, I think this is a good way to really kind of burn this stuff into your brain is go into the console, create your own budget using the billing tools, set up a budget, and set up some alerts. So when you're kind of studying and you're doing the billing section, if you want to, you could tackle this down. And then this could also be nice on your free AWS because then if you do start spending a couple cents for any reason, like the database service RDS costs money, you'll get an alert so you'll know that that happens, which can give you a bit more confidence in playing around with your free tier AWS account. So just to kind of wrap up here, we have these four billing tools, calculators for projecting, cost is explorers for looking at what I'm already spending. We've seen there's two alerting tools, and AWS budgets is more for forecasting costs and getting reports, and billing alerts is more for waking you up at 2 in the morning saying we're suddenly spending like thousands of dollars on EC2s because a meme has popped off. Um, and then there's some examples of sort of exam phrases here. I saw some folks had some questions. Tony, yes, sir.
It wasn't really a question, it was more of a comment. After doing the practice exam, I noticed that the budget was almost as prominent as the security when I did it. So I just kind of wanted to put that on people's mind. It seemed like every third question was about budgeting.
That's a really good point, and that makes sense. And if you think about it again, as a business, that I'm going to care a whole lot about budget, so that makes sense. Um, yeah, again, make sure you take a practice test if you haven't. I would encourage you guys to do all this for your free AWS accounts, because this is really useful that you'll get an alert if a cost exceeds $0, because you guys have a couple hours of like AWS credits, and that actually gets you extremely far. And there's like a monthly threshold that if you stay under it in terms of your spend. But once you start adding database services, they do like the Amazon RDS database service and some other services cost more. So if you do this, I think it'll give you a lot more confidence in playing around on your own personal AWS. So you don't have to worry about spending money, or it's like sometimes it might just be $1.50 a month, right? And you'd be shocked how much you can spin up with, just with that. Um, all right. Why don't we? Oh, and I apologize, guys. I think I got a little lost in the sauce here. I jumped into billing tools, which is actually part three of what we have today. I I was reviewing this, and that's why I got a little confused. So we'll backtrack a bit, but it'll be fine. Why don't we take a short break? Why don't we take five, and then we'll cover core AWS services and some costing information, and that will actually help a lot with this billing stuff that we just saw. Thank you guys, and I'll see you all in 5 minutes. All right. So to do a brief overview of everything that we're covering for this day three of the crash course, I had jumped ahead a bit to the billing part, but we're covering core AWS services, the tech, how AWS charges for them, the business. And Tony, like you were saying, a lot of the questions on the exam do hit this, right? And a good example is what pricing models most cost effective, or more business focused stuff like which support plan includes a technical account manager. We're going to just review core AWS services like Lambdas, EC2s, S3. I'm going to talk a little bit about Lambdas because they are important, just in general. We're going to learn about different ways of pricing EC2s. We did already cover the budgeting tools, but that's the agenda. And then finally, talking about support plans. So let's just dive right in and talk about the core services that we know and love. So AWS has some core services, and they all do different things. You don't need to be an expert on them, but we do want to know what they do and when you're going to use them. And that AWS Cloud Quest game is really, really good for this because it will have you spin up all of these core services and I think set up some billing alerts. So the first core service, the one that we're probably familiar with, is this EC2, Elastic Cloud Compute, right? The two C's, so EC2, which is basically a virtual server in the cloud. It's a virtual machine in the cloud. You get to choose the instance type. And in fact, we can go ahead and let's pull this up in the console. I get to choose a virtual server in the cloud. And as doing so, I can give it a name. I can choose what operating system it's running. And these days, Amazon Linux, that's sort of configured for these, is often the choice. Architecture, the instance type, how much power we want it to have, and you see all this information on it. And then there's a bunch of other settings, network settings. We can add it to security groups like we learned about the other day, and so on. And as mentioned, there's a pretty generous free tier for EC2s, and this is sort of the bread and butter. Now, after EC2 comes something that we have not talked a lot about yet in the course, Lambda, which is a serverless function. And these actually are a huge part of modern software development. And it's very possible that as you get into your career and your first job, you're using what's called a serverless architecture, where instead of writing a big backend like Django that's running on a virtual server, you're using what are called serverless functions or cloud functions. And let's talk about, for a moment, what those are. So there's this term serverless computing, and Lambda is an example of that. Lambda comes from this math term Lambda function, which is why we see it show up in Python as well, right? For lambdas that are sort of the equivalent of JavaScript arrow functions. And basically, the idea is I don't manage a server at all. This stuff is event driven. You pay per use. It has broad language support. And all you really have to do is write a function. And in fact, if we Google what is a serverless function, we get this interesting answer where imagine that instead of renting like a virtual machine on a cloud, someone's already got a computer up and running. And all I got to do is give you my Python code that I want to run, and it'll run it. And maybe I'm not even giving you like a Django app. It's just a function that takes an HTTP request and talks to a database and like gets the user profile and returns it. Basically, a Django view function could be just one serverless function. So rather than having a big architecture, I have all these small bits of code that are triggered by different events. So we don't have to manage servers. Different events trigger them and the functions run and then they're shut down. And to kind of just dig into this a bit more and to go into the AWS docs a bit, as it says on the business level, the idea is it really lets you focus on your code while it handles all the infrastructure management I don't even have to worry about spinning up multiple EC2s. AWS is doing that for me. And I'm basically getting sort of a platform as a service here, right? And there's some buzzwords around this: increasing developer agility, write less code, perform less maintenance, build applications faster, which is true. Application performance. It's not about how performant is Django, how performant is my EC2. We get to benefit from AWS's infrastructure. Because there's less code, there's less security risk. Because it's pay per use and cheaper, costs can drive down, and it gets used for all sorts of stuff. Instead of Django, you often have tons of little serverless functions, and this is what's called the serverless architecture. Um, Data processing, right? If I need to maybe go through and calculate payroll for thousands of employees, real-time data processing like chat and then Gen AI. I've also pulled up here the AWS developer docs on Lambda. Again, Lambda shows up, it's definitely on the exam, but the reason I'm hammering it now is because this is actually important for your career. So the goal of this right now is just get exposure to this idea of a serverless function and AWS Lambda. Don't worry about it now, file it away, but then after graduation, come back to it. Because this is how an awful lot of modern development works. And with the foundational knowledge that you guys have gained, you'll be really well set up to learn about serverless functions and write them. And I think you'll be excited by what you see. So as this describes here, um, basically imagine like a bunch of really powerful, beefy servers, a high ability compute infrastructure. AWS is managing a bunch of EC2s, Python's installed and configured. Everything is set up. There's scaling, there's logging, and all I have to do is write a function that, say, talks to a database and then returns data as an HTTP response. And I don't even need to worry about a server. And then I can sort of create events that would trigger this function. So all I have to do is write the Lambda function. I manage permissions, and then there are different ways to trigger this function. And then Amazon does the job of executing the code when it should, and I don't have to think about like scaling or anything else. So there's a lot here. I'll drop this link in the chat. And if someone could repost it, I'd appreciate it. And I realize that I'm throwing a whole lot of information out there, but that is the idea of an AWS Lambda. And again, while it's not like more prominent on the exam than these other services, it's such a huge part of modern computing that I wanted to take a couple minutes to touch on it. I do want to pause here to see if folks have any questions, and then we'll move on. Okay, cool. So moving on to some of the next services here, we have S3, which is a simple storage service, which we talked about a little bit before, which is basically a file server. They call it object storage because under the hood, it gets stored as objects, not files, but you can store files, videos, backups of things. It's highly durable. It has a high degree of reliability. Like in the service agreement with AWS, Amazon guarantees it's called, there's a term like 99s, like 99.9 more nines% available uptime. So they're guaranteeing 11 nines of uptime, basically, 99.99999. Because if you're a massive company like AWS, even with that super high guarantee, every now and then it'll go wrong. But so basically, it's saying, hey, if you need to build like mission critical software, you have a high degree of reliability with this tool. And you can use it to store log data. You often see other AWS services use this. So sometimes it's used as a tool in the toolbox. It's used for backup. It's used for static websites and media storage like videos and so on. right? If you wanted to build a baby Netflix, you would store your movies on an S3 bucket, is what it's called. Up next is something called elastic block storage. And this is basically a virtual hard drive that works together with EC2, EBS, right? So there's EC2 and EBS, and we often don't need to directly work with or configure this. But if I wanted, say, to have multiple EC2s sort of share one hard drive or mess around with how the database is sharing a virtual hard drive, I would mess around with EBS. And speaking of databases, Amazon has, they call it a relational database service. And this is a managed database. It manages backups, it manages logging, they manage updating to new minor versions, they manage scaling. And so it lets you have a nice Postgres backend for your Django app without administrative overhead. So I might combine this with an EC2. I might combine this with Lambdas. And it doesn't just have to be Postgres, it can be any kind of relational database. So this is a super useful tool. It does cost a bit more than EC2, which is why on the free tier we don't show using it when we demo how to deploy a full stack app to AWS. There is another kind of database that we haven't covered in this course. This one is also extremely important. It's called a NoSQL database. What's called formerly a document database. It's called NoSQL because it doesn't use SQL, though there's a little bit of an asterisk to that. And let's see. Let's get the AI mode results here. So a document database basically stores data as JSON. They favor scalability to make it fast to read to and write from and performance over the kinds of reliability and structure and relationships and data integrity that we get with a relational database. And Twitter is a great example. If I'm Twitter, I need to worry about, millions of tweets per day. And if I give up some reliability and structure in my database for speed and performance, that's a good trade-off for Twitter because a dropped tweet every now and then is not the end of the world. They became extremely popular for a while. Then there was a little bit of a backlash. These days, there is still a lot of overlap. Like Postgres has the JSON data type that lets you store JSON in there. And that's very similar to a document database or a NoSQL database where you're basically storing JSON, right? Rather than tables with columns and rows, you have quote unquote documents that basically look like JSON objects. And there's a database, MongoDB, that was really popular for a while as a NoSQL database. DynamoDB is Amazon's version of this. And these days, there is a lot of blending. The NoSQL databases have relational database features, and the relational databases have some of these NoSQL database features. Again, this is serverless. You get really fast performance. So like if I'm a startup and I'm prototyping, I might just use AWS Lambda and DynamoDB, like move fast and call it a day. I've already talked more about this than you'll need to know for the exam. The main thing to know is that DynamoDB is a NoSQL database, it's serverless, and it's fast, right? So we have these four key services that AWS provides. Virtual compute, storage, think hard drive for the virtual server or the virtual database, and then database services. Oh, and let's try that one more time. Compute, S3 for like media and file storage, block storage, which is our virtual hard drive for our EC2 and for our database. And then for the database, we have the relational databases and the NoSQL databases. So let's tackle a couple of these practice questions. And I believe next on our list is Bryson, who may not be here today because he has been dealing with extremely inclement weather, unfortunately. Alex, for this first question here, which AWS service lets you run code in response to events without provisioning any infrastructure?
Lambda.
Yes, sir. Good job.
Come on.
So this is the key term, without provisioning infrastructure, meaning servers or EC2 and events as in event driven. An event could be an HTTP request. An event could be a serverless function, fires an event for another service. We got a preview of events with DOM events. If you guys remember DOM events and bubbling, and that idea of an event-driven architecture isn't just in the DOM. You see it all over the place. You see event systems, and so here we see events on the back end, so to speak. Question two, Sam, you need object storage for images and video files. Which service should you choose?
S3.
Yes, sir. Yeah, and good job. This is a lot of jargon, right? But we now know what the heck EBS versus RDS versus S3 versus DynamoDB is. And S3 is our bucket for storing files, images, videos, media, our object storage. Next up is Arnold. Which AWS service provides virtual machines with customizable instance types?
EC2, Elastic Compute Cloud.
Yes, sir. Good job. Right. Elastic Cloud Compute provides configurable compute capacity in the cloud. And that's a lot of C's right there. Note that they threw in something we haven't even talked about yet, cloud formation. Exams love to do this. My strong advice for a multiple choice exam is don't second guess yourself. Go with your gut and don't be afraid to strike something off the list. I think it's always tempting to be like, I'm not sure what that is. It must be the answer. I know I always kind of fall prey to that. And usually it's the opposite, right? When in doubt, go with your gut, strike the other ones off the list. And in the spirit of learning, let's actually look up what cloud formation is. And this is how I like to review practice exams or quizzes once I do them. Like, I view this as this is a great chance to turn some jargon that I had no idea about into knowledge. So this is an infrastructure as code service to model, provision, and manage AWS and third-party resources, blah, 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 templates, stacks. So I'm still struggling a bit to feel like I know exactly what this is. Let me look at their website and see if it helps. And as I look at this, so this is a bit more DevOps, but basically I can write some config files, kind of like Django settings PY, that I can use CloudFormation and I can feed it a config file and it will create EC2s and Lambdas and a DynamoDB and RDS or infrastructure. So I can write code in the form of this sort of config file format and CloudFormation will spin up a whole infrastructure for me. Moving on to our next question here. And up next is AJ. Let's see. And AJ may not be here. I think he's working on his project.
No, I'm here.
Oh, perfect. All right. AJ, which service is used to provide persistent block level storage to an EC2 instance?
Block levels, probably the block store B.
Yeah, there you go. Good job. Thank you, sir. Elastic block storage volumes attached to EC2 like a virtual hard disk. And again, putting on my old GRE standardized test teacher hat, when a question seems blindingly obvious, it probably is for these kinds of multiple choice exams. You
Oh,
know,
good. Because I wasn't certain, but when you read the question, I was like, it has to be that.
yeah, exactly, exactly. And up next, we have Tom to take us home. Which service is fully managed and supports relational databases like MySQL and Postgres?
Let's see. RDS.
Yeah, good job, man. Um, so RDS, Relational Database Service, supports all the different kinds of relational databases we would want. Fully managed means that Amazon is responsible for creating it, scaling it. If we have tons of database traffic, Amazon will deal with it, backups, patching minor version updates, and all that good stuff, which is kind of what you want for a database, right? It's kind of nice to have someone fully manage it. So we've covered core AWS services, EC2, Lambda, EBS, RDS. We've turned this from jargon into knowledge. We have a fundamental understanding of when to choose one over the other, and we've seen some of these in scenario questions, and we did a bit of a deep dive into Lambdas along the way. What questions do folks have, and is there any, what are people curious about? Okay, awesome. Should we take five before we continue on? Yeah, let's go ahead and take five, and then we'll hit pricing. Thank you guys, and I'll see you all in 5 minutes. All right, so we're going to talk about pricing models. So the thing about cloud compute is now that Amazon has this amazing infrastructure, they have a lot of flexibility in how they can offer to rent it to us, basically. Um, there's three different ways to rent cloud compute or other services, but EC2 is the most common example. Um, so on demand is sort of what we saw in a sort of the default pricing. And basically, this is whenever I want an EC2, they will provide it. So if I'm developing, this is useful. I'm building and prototyping and testing, or I don't know like when a workload is going to happen. It's really flexible, but it costs the most. Now, if I know I'm going to have my web app up for the next year and I know there's going to be traffic and there's going to be, maybe like 1,000 visitors a month, maybe sometimes 2,000. Maybe I just want to tell Amazon, hey, I want to reserve an EC2 for a whole year. And this, because they know I'm going to use it for a longer period of time, it lets them, however they're dealing with their data centers and their resources under the hood, provide it to us at a lower price, but we pay upfront for the whole year. And if I don't use as much as I thought I did, so be it. I'm still paying. And then finally, there's something called spot, where maybe if at like midnight every day, I need to like review employee timesheets and like run some sort of background job that happens irregularly and it doesn't have to happen on the dot, like as long as it happens between midnight and like 4 a.m., I'm fine. It's fault tolerant and it's flexible, then that gives Amazon a lot of flexibility in when they provide us that EC2. So they can give us a big discount and but they're saying, hey, we're actually not going to guarantee this. This job might get interrupted and have to be restarted. Right? So there's kind of like a market for this. So these are the different pricing models: on demand, reserved, and spot. Right? And on demand is flexible but expensive. Reserved is less expensive but committed. And spot is discounted, but we have less control and it's not 100% reliable. They might have to restart it. Which again, if I'm just need to send out like 1,000 emails at midnight every day, that's a job for a spot instance. And if it stops halfway through and then picks it up 5 minutes later, not a problem. If I need like time sensitive stock price information, I'm going to need probably on demand or reserved. And I'll dig a bit more into these in a minute. And in fact, let's dig a bit more into them now. And let me hop over to AWS and the pricing page so we can see these. So on demand, you pay per second. There's no commitment. This is sort of the default setting for developing, testing, unpredictable workloads. It's really simple to use. It's also the most expensive per hour, right? And here we see this on-demand instance, pay as you go. A savings plan is what they're calling the reserved instance. You can save a ton of money, right? It's kind of like, with a credit card, the credit card companies make money off the people that don't pay the credit card on time. Where if I'm committing to like a 1 year term to pay for a year of EC2 use up front, I can get a deep discount, but I'm paying for the whole thing. So if I have an always on workload, like if I know I'm getting like 1,000 visitors a month to my website, like regularly all the time, I might just buy a year's worth of EC2 at a nice discount. Um, and then we have our spot instance, super cheap. It's basically spare capacity, but it can be interrupted within 2 minutes notice. So it's more for like background jobs or what are called batch jobs. If I have like, you know, maybe we're calculating annual Christmas bonuses for 100,000 employees, and I just need a bunch of work to happen in the background over the next week. So I'm dealing with a bunch of data. You wouldn't want to use it for a critical or time sensitive workload, though there are like auto recovery options. So this is where it starts to get a little more interesting and complex. And you can kind of look at all this stuff. And this is what the pricing calculator can help with, as you can kind of like enter EC2 information. We can see some pricing information here. Oh, excuse me, this is the performance information. Over here is the pricing information, where we see the on-demand hourly pricing and it's fractions of a cent per hour. And I think if we scroll down a bit here, we can see, and let's choose an option. Let's make this a bit more expensive just so we can see the pricing increase a bit. Right? So we can kind of see this pricing stuff change, though it's not, I think, as interesting as I hoped to play around with to see the sort of discounts. As you can see, the pricing calculator itself is a little tricky to play around with. So I don't think we get like sort of the best. There we go. We can see a spot discount. I don't know if it'll show us the other discounts, and it's probably not worth it. But they have a bunch of documentation around this and something they called savings plans now that can be used with reserved instances. They say you can get like up to a 70% discount over the on-demand pricing, which is true as long as you're willing to pay like for a year's worth or 3 years worth of compute upfront. And then they have pricing calculators again, where we can see here and you can see the different options and how much, you save over a year versus on demand. So again, imagine that I'm Netflix and I'm spending millions of dollars a year on my cloud compute and my cloud infrastructure costs. Netflix is easily spending millions a year on their cloud compute. This stuff really starts to matter. And again, as junior full stack engineers, we're not going to be encountering this, but it is good to start thinking about things this way, right? And just to think about like what kind of stuff would need an on-demand, EC2, obviously to have, say, a website up. What could I use reserved for? Again, if I have consistency, if I know I'm going to have a website up for a while, if I know I have a certain amount of traffic, what can happen in the background and is less critical? right? If I'm sending a daily email newsletter, that's not something I need to like pay on-demand pricing for. I can use spot pricing for that and fire that out at midnight every day. As mentioned, they do now have savings plans. Um, this applies to other services as well. It's like a reserved instance, but it's more flexible. We haven't really talked about Fargate. We talked a bit about Lambda. Um, as long as Fargate has come up, just so we can go from level 0 to level 1 on it to know a little bit about what it is. It is a serverless compute engine that lets us actually run sort of containers serverlessly. So I could run Django in a container and have the whole thing stop when I'm not using it. Um, that is a bit too deep of a well to go down now, but Fargate is a serverless compute engine, and just note that one away. So if you see the term pop up on the exam, we have some familiarity with it. And I've lost track a bit of where sort of my TL draw was. So let's just pull up another one. And now let's dive into our practice questions. And I think we're going back off the top here. So, Ryan, what EC2 pricing model is best suited for workloads with predictable long-term usage?
Is it reserved?
Yes, sir. Reserved. A lot of the exam questions, again, are going to be pretty straightforward. Reserved instances, they're steady, long-term workloads. They offer a deep discount, but you got to pay a year in advance. Just like, if I sign up for Netflix or whatever, they're going to give me a discount if I pay a year in advance. Um, Cricket, what is the downside of using a spot instance?
Discount. There will be interrupt C.
Yeah, see, a spot instance on the spot, as in, actually, that's not the best metaphor. I apologize. I'm not sure why they call it a spot instance, but a spot instance is less reliable. AWS can interrupt it a little bit. They're basically renting us their spare capacity at a cheaper at a cheaper price. Excuse me. And there's a 2-minute warning if AWS needs the capacity. And Rick, what EC2 pricing model provides the most flexibility but at a higher cost?
I want to say, but at a higher cost. Ooh, that's spot or reserved, or I'm sorry. I'm gonna say, I was wrong. On demand.
Yeah,
Okay,
on
yeah, on
demand.
demand's more pricey.
Yeah, on demand. I think the way to think about it is on demand is the default, and the default is more expensive. You get the most reliability, you get it right when you want, but they charge you the most for it.
Okay, all
Um,
right, yeah, that makes sense. Because
yeah,
the other ones are based on load, basically. It sounds like.
yeah. Basically, it's like, you know, they have this giant pool of compute. It's basically a marketplace. It's not unlike the stock market in some ways. There's a giant pool of computing resource that they have, and they're gonna charge, you know, the same way where if I want like groceries delivered to my house or I want like ice cream delivered to my house immediately, well, DoorDash or whatever will provide it, but they will charge me more than if I go later and go to the grocery store. Um, Not the perfect metaphor. I think on demand is the default, and the default is expensive and on demand. Next up is Chris. A startup runs a batch job that can be restarted if interrupted. What pricing model offers the best savings?
Uh, Spot.
Yeah, I think the way to think about spot is temporary. right? Spot is spare capacity. That's going to be my sort of alliterative suggestion for remembering these things. Spot is spare capacity. Spot instances, they're ideal for batch, for flexible workloads that can tolerate interruptions. And then, Tony, what does AWS require from customers to receive the reserved instance discount?
C, upfront time commitment.
Yeah, exactly. You got to pay up front. You got to pay for a 1 or 3 year commitment to receive the cost of savings. Right. So as a DevOps engineer, I might spend several weeks calculating what I think, our compute needs are going to be for the next year if I'm at a big company, before purchasing a whole bunch of reserved instances. That might be an important part of my job that has very little to do with code, but everything to do with software engineering. So we've now covered the three EC2 pricing models. On demand is for flexibility but costs the most. On demand is the default. Reserved, you pay up front for predictable savings. On the spot is spare capacity that's cost efficient and for interruptible workloads. And we've talked about their trade-offs and saving plans. Thank you guys. And what questions do folks have or what's on people's minds? Okay, awesome. Our last lesson to cover, we kind of hit billing tools first, so I did it a little backwards, but we covered the different kinds of compute resources. We covered their pricing, and then at the beginning we're kind of circling backwards here, but now if you think about, we have the bigger picture of all the different compute resources and the different ways that we can pay for them. And that sort of helps emphasize, I think, the value of these billing tools that we covered earlier for like trying to estimate how many reserved instances I want to buy for my infrastructure for the next year. Um, Analyzing past costs to see where I can manage costs. Maybe we're spending too much on reserved instances. Sending spending alerts so I know if my on-demand EC2 spend goes really high, and then and projecting, and then a billing alert if for some reason I see a huge spike in on-demand like immediately. The last thing we have to cover for this lesson is support plans and costs. Why don't we take a short break? Why don't we take 5 and then we can dive into support plans? Sound good? All right. Thank you guys, and I'll see everyone in 5 minutes. All right. So the final part of today's lesson, we've learned about the core AWS services. We've learned about how they get priced out. We've learned about the billing and budget management tools. We're going to talk about different AWS support plans and cost optimization techniques. So there are 4 AWS support plans, and we'll learn about some of the core ideas around cost optimization. Tony, like you were saying before, a lot of the exam focuses around these things related to cost. So expect to see questions talking about which plans include 24/7 access or a technical account manager, someone who knows a bit about this technology, right? Who they might not be a software engineer, or maybe they transitioned or out of software engineering to technical account management and it's sort of tech adjacent now. And what these plans are and who they're designed for. So this is pretty straightforward. The basic plan is the free plan. There's no technical support. There's billing and there's documentation, and that's really all the support you get. It's targeted for hobbyists or folks like us who want to just be able to kind of play around in the waters, or like an individual, or like super early stage startups that haven't gotten very far yet. But even if I'm a startup, like if I'm actually, putting real money into the new version of pets.com, and or let's say like a flower delivery service, because I used that example before, and I'm starting to get real customers, I start to need a certain level of support. Like if something goes wrong, I might need some sort of response time from the AWS side. So the developer plan includes email support only for 12 to 24 hours, and basically like one contact person. And this is really for small startups, and or like a development test environment. If I'm a business and maybe I have a couple million in revenue, at that point I might need to make sure that if there's an issue, I can get 24/7 support via chat and phone. You get an AWS trusted advisor, you get support for the production, the live environment. And again, this is targeting small to medium businesses, um, which are bigger than you'd think. Like Code Platoon, I would put firmly on the developer side here in terms of size. So think like hundreds, maybe low thousands. And then enterprise support is going to cost an awful lot of money. But if you are Oracle or Netflix or Citibank, you are more than happy to pay someone a whole lot of money just to make these problems go away so you don't have to think about it. And you get 24/7 support. You get a technical account manager. You also get, I guess, a concierge to just really hold your hand. They'll give you architecture reviews, and this is for corporate, right? Big companies that have like large mission critical stuff on the cloud. So the basic plan is free. All these others cost money to increasing degrees. The developer plan, right? Only email access, no 24/7 chat support. Business plan, you get 24/7 chat and phone support and what Amazon calls a trusted advisor. Enterprise plan, you get probably someone who has done some software engineering, a technical account manager, and concierge services. So again, think it scales up from developer, email only, no 24/7 support. The business plan, you can get someone on the phone and a trusted advisor, but if you really want some expertise, you got to pay a whole lot on the enterprise plan for that technical account manager and concierge. Um, Moving on, even on the enterprise plan, you really need people on your team who understand AWS. The folks who used to be a sysadmin, whether it's a Linux system administrator or a Windows system administrator, the folks who used to be IT, tech support, or not tech support, but really IT, a lot of those folks now are managing cloud infrastructures, whether the title is DevOps engineer, cloud engineer. You'll see the term infrastructure engineer or platform engineer, which is a little different. You'll see the term site reliability engineer, which is similar to DevOps. So the cloud can encompass folks who come more from the IT operations side or the software engineering side. But either way, if I'm paying some real money, I'm going to want someone to be doing some cost optimization here. And Amazon actually wants customers to be able to be efficient and save money, um, because they don't make their money from they make their money from the win-win situation. They want people to be happy with AWS. Um, and AWS is not the only option out there. Microsoft Azure. AWS was the first big cloud infrastructure provider, but other companies followed suit. Um, Microsoft Azure is Microsoft's cloud infrastructure that has all the same things as AWS that are available. And then Google has, I believe it's just called Google Cloud. Google has Google Cloud's infrastructure, which is Google's version of AWS that offers all the same things as AWS. And obviously, there are differences between the three, but fundamentally, they all do the same thing of providing a cloud infrastructure as a service or a cloud platform as a service and various flavors of the above. And you guys may or may not know, but there was a huge bidding war in the past year or two for was a big government cloud contract. A bidding war for a government cloud contract between Amazon and Microsoft and Google, and I think Amazon ended up getting it. Let's see if we can find it here. Um, and then Oracle has a cloud as well. It looks like they ended up splitting it. Um, I thought one company had won it, but there's been several of these things, so I might be thinking of multiple things. But point being, AWS has competitors. So they actually really do want their customers, and they make their money from their big customers. They want their big customers to be happy and to be able to save money. So cost optimization is something they actually really kind of want to help us with. They're still going to charge us a lot, but they're going to help us with it. So there's a term right sizing, right? Which is if I need to send lots of emails every day at midnight, use the right kind of EC2 instance. Um, excuse me, this is probably I'm kind of mixing stuff up here. Right sizing is basically don't choose an overpowered EC2 to do my work. Use the smallest amount of resources that I need. Maybe when I first launch my service, I use some beefier EC2s. Then 6 months in, I use the Cost Explorer and I see that, my EC2s aren't working as hard as I think. I can use a cheaper EC2. Or, we scale up. There's a term auto scaling. An easy way to scale up capacity is not by using a beefier EC2 that actually doesn't really scale very well. The best way to scale up capacity is you don't make your EC2 bigger, you make more EC2s. Because since we're dealing with a cloud infrastructure and virtual servers and virtual compute, I can do this all day long. And so AWS actually has tools. In fact, there's something I believe it's called like load balancer or auto load balancer to automatically spin up more EC2s when traffic increases. And I can set rules around this. And then to automatically spin them down so that when the holiday rush to order flowers online stops, we spin down the EC2s we don't need. So auto scaling is a super important cost management technique, and you don't avoid paying for resources that you're not using. Next is using spot or reserved instances for different kinds of jobs. And as we talked about, spot is for fault tolerant jobs like sending emails at midnight, batch jobs. Reserved is predictable workload, like I know I'm getting 1,000 users a month for the next year. Um, you'll be shocked at how quickly it is to lose track of what you have in the cloud. There is always wastage. So paying attention to what you have. And in fact, Code Platoon created a sort of an automated bot to check what the AI cloud ops students are doing and reminding people to turn off resources. Because Amazon has dozens to hundreds of teams. Or to use an example, Netflix probably has hundreds of engineers and dozens of engineering teams within the overall department. It's actually pretty easy to lose track of stuff. So you gotta use the tools available to pay attention and remember to turn the lights off and turn down the thermostat before you go on vacation, so to speak. And then finally, budgeting and alerting. Right. So when it comes to cost optimization, we've got right sizing. Don't use a more powerful virtual computer than you need. Auto scaling to spin up and spin down EC2s. Using the different pricing availabilities for spot or reserved instances for EC2s. Turn off the unused resources, whether it's a database or compute, turn down the thermostat, like, when you go out before you go on vacation, and then the budgeting and alerting. And here's a nice diagram we have covering the basic free plan, the developer plan, where you just get the 24/7 phone call or email with someone who may or may not, uh, I think, be useful. The business plan, and then the enterprise plan where you get the technical account manager and the concierge. And then we've got our cost optimization graphic covering these things that I just walked through. All right, so let's dive into some practice questions here. And let me go ahead and let's see who is up next on our list. I lost track of where we finished up actually right at the bottom. So let's just start at the top. Ryan, which AWS support plan includes a technical account manager?
Is it the, God, I think the business? C? Oh,
It
D.
is the enterprise plan. I think the way to think about it is the technical account manager is the expert, and you only get the expert on the enterprise plan. The business plan, I believe you get 24/7 support. Though hopefully I didn't give away the answer to question two. Uh, Cricket, a startup wants 24/7 chat and phone support, but doesn't need a technical account manager. What plan should they choose?
That is business.
Business plan. Yeah. So the business plan provides 24/7 access without a technical account manager. The developer plan provides a little, but not a lot. You don't even get 24/7 support. Um, Rick, what of the following is not a recommended cost optimization strategy?
Alright, is not. uh, I would say size. I would say auto scaling C is not an optimization strategy. Billing, I think, would be because it alerts you when billing goes up, so then you can cut back some of your costs. So that's cost optimization. Right size instance. Maybe on demand, really not because it just goes, you know, I'm gonna say C, but it might be A.
So it is,
Oh, not even close. All
yeah.
right.
So using billing alerts, absolutely cost optimization. Auto scaling actually is a cost optimization strategy because with auto
Okay.
scaling, I've got basically an automatic load balancer in front, and when traffic increases, it'll make more EC2s. It'll
Yeah.
automatically scale them up, but it also automatically scales them down when traffic drops, which is where we get the cost optimization. I will say, by the
Yeah.
way,
On demand is pretty expensive. Maybe that's why it's not cost effective.
exactly, this is the most expensive version, so just using it for everything is not cost optimization.
Yeah. All
Yeah.
right.
And again, half the
Yeah,
challenge
I
with this
see that. I
exam,
just,
yeah, half the challenge with this exam is just there's a lot of jargon. And that's why at a certain point, just lots of reps and sets on quizzes and practice exams is by far the most efficient way to study for this. And thank you guys. And let's see, next up we have um Chris. What AWS tool can help enforce a monthly cost threshold?
Budgets.
Yes, sir. Right. Budgets allow us to define thresholds. So C and D note are about completely different things. Though the word shield is tempting, right? Because we have this word enforce. But since budgets and cost explorer both talk about money, like even if I don't know what these are, if I have to kind of, guess this question cold, I'm basically going to flip a coin between A and B. And yeah, it's AWS budgets. Um, Next up, and thank you. Tony, a developer wants minimal cost access to tech support for dev test workload. Which plan should they choose?
B developer plan.
Yes, sir. All right, gentlemen, thank you very much. We've covered everything here on the third lesson in AWS. We've got the four support plans, a technical account manager, optimizing spending, and how the exam phrases support, or sorry, I'm losing my words here. How the exam talks about these things. Let's take five, and then we will move on to day four, and we'll talk about how much of day four we want to cover. Thank you guys, and I'll see everyone in 5 minutes.